So last week, I looked at the low-level mechanics of interacting with an Amazon SQS queue inside of Lucee CFML. But all I really did was write a message to and read a message from an SQS queue. I didn't actually integrate that queue holistically into a Cold Fusion application. So today, I wanted to take a look at how you might more broadly embed a queue into a Cold Fusion application, and more specifically, think about the separation of concerns when we do that. So to set up this exploration, I have a simple concept here where I have an input and I can enter a hex value. And I submit that, and you can see it's being monitored here in the background. And then that hex value gets massaged and generated into a PNG color swatch. So this is an actual physical image that's getting written to disk. So the way this works is when I enter the hex value here, it gets pushed onto a message queue. The Cold Fusion application is long-term polling that queue, which is what you're seeing down here. We're pulling the message off, we're taking that hex value, we're converting it to a PNG, and then we're refreshing this page. So how do I draw boundaries that keep all those little pieces decoupled from each other and easier to maintain over time? Well, the lowest level thing I can do is generate this color swatch from an hex color. So that's the very first thing I do. So if we jump into the code, what I have here is a Cold Fusion component that does nothing but expose two methods, generate swatch and generate swatch file, which take a hex color and then generate the PNG and write that PNG to this destination. So this Cold Fusion component doesn't actually know anything about message queues at all. It's simply an isolated piece of functionality that can take the hex color and generate the image. So then how do we get from that hex color to this image? We have to go through the message queue. And for that, we create what I'm calling the glue layer of the application, which is the Cold Fusion component that understands the queuing mechanism and glues the queue to the greater application context. And if we jump back into the code, that's what my next Cold Fusion component is. It's the color swatch queue service. And when I instantiate this service, it takes two dependencies. It takes the SQS client, and that is a client that talks specifically to these hex color message queue. And then I take that color swatch service that we were just looking at. And this is the service that knows how to convert that hex value to an image. So it has a couple of CRUD style methods. When we add a message, so we give it a hex color, it's going to push that color onto the message queue. We can delete messages given the various message. That's not very interesting. But mostly we have these two process message methods. We have process message, which takes a given message, and this is truly the glue of the application. This understands how to convert this message queue concept into the broader application context. So it's taking that message, it's deserializing the content, it's taking that hex color, it's getting the file destination for it, and then it's turning around and it's calling that color swatch service, generate swatch file. Again, it's passing in the hex and returning, passing in the hex and the destination. So this is generating the actual PNG. Now this method is being called by this method down here, process new messages. This is where we actually perform one long poll against the Amazon SQS queue to look for new messages, and then we're going to iterate over them and process them above. So this glue layer understands the SQS concept, it understands the larger application context, and it glues those two layers together. But it doesn't necessarily know about the long polling. Yes, it can do the long poll here where it waits for up to 20 seconds for new messages, but that's a one-time operation. It's not actually doing that over the long term. So we need another layer that understands the long polling, but doesn't have to worry about all of this other gluey stuff. And that we're going to implement with a Cold Fusion scheduled task. So if we look in our application CFC file, we can see that I define a scheduled task during my application initialization, and it's going to call out to this color swatch queue manager, and it's going to execute every 10 seconds. Now, if we look at this code, this is our scheduled task, and the first thing we do is synchronize access to it because we don't want to necessarily have two processors overlapping with each other. So we're going to create an exclusive named lock here, provide a timeout of 1, but don't throw a timeout, don't throw an error on timeout. So essentially, if this is going to run for a really long time and then the scheduled task runs it again, the second overlapping instantiation of this template is simply going to exit out no harm, no foul. If we do obtain the lock, meaning we're going to kick off that polling, then I adjust the runtime in seconds for the request, because we're going to want this to sit there and poll for quite a while. And then all I do is kick off a while loop that will call that process new messages on that color swatch queue service. So this is the thing that's actually going to sit here in the background, telling that glue layer to continue to look for new messages. So this layer doesn't actually even know about the queuing mechanism. It just knows that it has to sit here and run this line of code over and over and over again for as long as it possibly can, until it eventually reaches some maximum timeout, and then it exits, at which point the next iteration of the scheduled task will be able to obtain the lock, and we essentially start this over again. And then to pull it all together, let's just take a look at the demo file itself. It's very simple. All we have is our form. We have our hex color input. When I submit the form, up at the top here, you can see all I'm doing is adding that message to the message queue. And then I'm querying the local file system for PNGs, and then we're just outputting those. So what we have are a bunch of pieces here that are all very focused in their domain of responsibility. We have our color swatch service, which knows nothing about queues. It only knows how to take hex colors and generate PNGs. We have our color swatch queue service, which understands how to glue the concept of the message queue to the greater concept of the application, but doesn't know how to maintain a background thread of polling. And then we have our scheduled task, which understands how to maintain the background thread of polling, but doesn't actually even know anything about how queues work or the fact that we're generating color swatches. All it knows is that it has to run this line of code over and over and over again until the end of time. Which means that we could take the scheduled task and we could swap it out with a completely different implementation. Maybe it's a task thread. Maybe we want to run this inside of an asynchronous thread. Maybe we're using something like a future. We're using Coldbox's async library. We can swap that out, no problem. And we can swap all these pieces out, no problem, I think, right? I mean, I'm learning as I go here, but I think this is a nice separation of concerns. So anyway, the journey continues, learning a little bit more each time I try this stuff. So hopefully something here was interesting and not terribly wrong.